we already discussed how to graph something squared. But most of you graphed it as a straight line. Right? So this is x squared shifted where? No, not up. To the right. Right? So when you graph x squared, you graph this. When you graph x minus 2 squared, you graph this. Of course, this is a different situation. It's a piecewise defined function. But you graphed a straight line. Right? I'm not saying, I don't know. I just saw it in a couple. I can't tell you, and it's not important. Right? So please be careful, bless you. Remember the first thing I ask you when I start graphing is domain. So this changes into negative infinity 3, and this changes into 3 to infinity. So I put those negative infinity, 0, 3, infinity. I put the symbols right under it. Then I write that this is x minus 2 squared. And then I write that this is x plus 3. And the next thing I ask you, what type of function is this? So I don't forget how to graph it. And then I ask you, what type of function is this? So I don't forget how to graph it, right? That's the key. Okay, so now I know that this will be the graph of this. Something like this, just to the right, to the left of 3, not more. So if this is 2 and this is 3, this will be the graph that I'm looking for. So at negative 1, I have negative 1 minus 2, which is negative 3. Negative 3 squared is 9. 0 minus 2 is 2. 2 squared is 4. And then I will put also 2, because 2 minus 2 is 0. 0 squared is 0. And then 3 minus 2 is 1. 1 squared is 1. Way too many points. But just to make sure that I'm graphing. Okay, and then on this side I have 3. 3 plus 3 is 6. And then 4, I have 7. I know that this is linear, quadratic. So I don't forget. Write it down if you know, we all forget, right? Okay. So then, first of all, I'll write that the domain is definitely all real numbers. And now I have to wait and see the range. I don't know. Negative 1, 9, whatever. 0, 4, 1, 2, 3, 4. 2, 0. 3, 1, open. I know this is the graph because I know how to graph x squared. Now 3, 6, so this was 4, 5, 6. And this is a full point, and 4, 7. So now the range, obviously between 0 and infinity. So always ask yourselves, okay, what am I graphing? So first domain, without which I can't start. Then I look at those functions and say, oh, this is quadratic. Oh, that's linear. Okay? Good. So moving on. I think this is my page 3. Yes. We are in the middle of transformations, and we looked at, yes?
Do you think if we forget, if we plot enough points, will we still look up the graph?
I have to look.
Okay.
I can discuss that situation
Okay.
till I look at it. Yeah. Okay, so we looked at, yes, please. No, not yet. I will remind you at the end of the class. If not, please remind me. As one of my, I think I told you, as one of my professors used to say, when you get to the stage in which you have to start writing down stuff, because otherwise you forget, he used to say that the next stage is you will forget where you wrote it down. So I think I'm at that stage. I forgot where I wrote it down, so please remind me. Good. I hope so. I hope not, but I think I'm getting there. Okay. We're talking about, let's look at a function. I'm going to use a combination of things here. Negative the absolute value of x plus 2 plus 3. We are asked to graph this function using transformations. Use transformations. So in other words, I do not want an exact graph. What I could add to this is find X and Y intercepts algebraically. In other words, do not read them from the graph, determine them exactly. Okay, so remember we said transformations have to be presented in order of operations. So first I have to identify the base function, the simplest possible function used to determine f or create f. What was it? The absolute value for sure. Now two, imagine that you are evaluating this function. What will you evaluate next? Never. This is not a grouping symbol. So note the absolute value is not a grouping symbol. G-R-O-U-P, okay, symbol. I thought I missed a letter. So it's not a grouping symbol, you cannot treat it as such. Okay, so what will you evaluate next? Will you add 3? No, you can't. Will you multiply by negative? No. So what is the next operation in line? Exactly. X plus 2. Where will the graph go? Left 2. The next in line, after I'm done with this, what will I do? No, I'm not there yet. In order of operations. In order of operations, after I'm done with this, which operation will I perform next? Multiply by negative 1. Negative x plus 2. What does this do to this function? This? Yes, with respect to the x-axis indeed. Because this is y, this is negative y. Y, negative y. So this is a reflection, WRT, with respect to the x-axis. Very good. And now 4 is the final function, negative x plus 2 and plus 3. What does this function do to number 3? Not to 2 and not to 1. What does this function do to number 3? Up. Because this is y and this is y plus 3. There is no change in x. There is a change in y. Y plus 3. So up 3. So now I will quickly graph it. I'm going to graph the absolute value first. I'm going to shift it left 2. I'm going to reflect it with respect to the x-axis. And I am going to shift it up 3. So this, you don't have to do this, I just wanted to emphasize the final function. So this is final, f of x, negative x plus 2 plus 3. Now let's say we are asked to to determine the x and y intercepts. So how do I determine the x-intercept? What do I have to make? Excellent. I have to make y equal to 0. Negative x plus 2 plus 3 equals 0. We know how to solve such an equation from the previous chapter and the test. What do I have to do first? So negative x plus 2 equals negative 3. Then divide or multiply by negative 1 is correct. Very good. And then I know this has 2 options. It's not a linear equation. So the first option would be
X plus 3 plus 2.
very good. And the second option is excellent. So I subtract 2, so I get 1. I subtract 2 and I get negative 5. So there are 2 x-intercepts. 1, 0, negative 5, 0. Kind of. In my graph, yeah, it was not too far. Negative 5 and 1. Pretty good. And now I have to find the y-intercept. How do I find the y-intercept?
X6 equals.
Yes, I have to find f of 0. Let's do this together. How much is 0 plus 2? The absolute value of 2? 2. With minus in front? Negative 2 plus 3? 1. So it appears that it's 0, 1. Let me look. Yeah, not too bad. Otherwise, like before, I would have had to make some adjustments. I'm fine with that. Any questions? Any questions? So now we know several things. First of all, we know shifts, left and right, up and down, and we know reflections. Reflections with respect to the y-axis, when I change x into negative x, and when I change y into negative y, reflection with respect to the x-axis. Okay? We have 2 more transformations to look at. One will appear to be self-explanatory, the other one not at all. But I'm going to try to make it as simple as possible so we understand what's happening. So we're going to talk about vertical stretching and shrinking. Okay, so let's look at f of x equals the absolute value of x. And using this base function, I want to create f1 and f2, 2 other functions. And this will be 1/2 the absolute value of x, and this will be 3 the absolute value of x. First of all, let's identify what changes. Is this a change in x or a change in outcome, or y? Yes, because x is the same, I did not touch x. X does not change into anything. Just the number in front. So this is y times 1. This is y times 1/2. This is y times 3. Because there is no change in x. Okay, so I know this looks silly, but maybe this will trigger your memory from now on. So this is the absolute value of x. If I multiply all heights for each point, just the height, by 1/2, will I do this or will I do this? But this is not shrinking. This is shrinking. So am I doing this or am I doing this? Okay, don't say anything. So this is the absolute value of x. So for x equals 1, I have y equals 1. X equals 1, y equals 1. So this is the point 1, comma 1. Where will this point go for this function? When x is 1, y will be, say again? Right. So when x is 2, so you have your answer. If I multiply all y values by 1/2, the function does this. It's a vertical shrinking of the graph by a factor of 1/2. So vertical shrinking. Okay, now can you please tell me what happens to 3 times the absolute value? Right? All y values get multiplied by 3 now. So this 1 becomes 3. So when x is 1, the answer is 3. When x is 1, the answer is 3. And so on and so forth. So this will be 3 times the absolute value of x. So every time we multiply y by a number less than 1, vertical shrinking of the graph. And every time we multiply y by a number greater than 1, vertical stretching of the graph. Okay? So this is vertical stretching. Vertical stretching. Yes, please.
Be the absolute value of x.
Say it again. What if this is -3?
Negative.
So you're making a new function. Very good. So here's f3, which is -3, the absolute value of x. How many transformations we have here? We have to break them down, although you will say, but wait a minute, I multiply the answer by -3. I don't multiply it by 3 and then by -1. However, when we look at transformations, we have to break this down into two steps. The absolute value of x, step 2, 3 times the absolute value of x, and step 3, -3 times the absolute value of x. This is the base function. What will this do to this function? Vertical stretching by a factor of 3. Now what will this do to this function? Exactly. Reflect with respect to the the x-axis. Ready? So here is the absolute value, right in the middle. Here's the absolute value of x plus 3, of 3x, I meant to say. 3 times the absolute value of x. And now I reflect this, and I get this. This is -3, the absolute value of x. Perfect. Perfect question. Okay, now the last one. The last one is not self-explanatory. All the other ones, I think, are kind of common sense, but the last one is not. So before I present the last one, which is horizontal stretching and shrinking of the graph, I would like to talk about the following situation. Let's suppose we have f of x, which is x cubed. If I discuss this, it will be easy to understand the last transformation. Now, if I ask you to find f of twice x, what will you do? You will replace by, good, and you will have to, yes. How do I cube a product? I cube each factor. How much is 2 to the third? How much is x cubed? X cubed. So when I'm making myself a note, when x was replaced by 2x, the function suffered, and we'll see in a moment what. Okay. We did have this transformation a minute ago. Remember x cubed. This is x cubed, right? And how will I graph 8x cubed? Remember for a minute ago we had this. And then this was 1/2 absolute value. And then from here, this was 3 times the absolute value. Now I want to think in terms of x cubed. Exactly. But remember, I changed x into twice x. You would have expected this to happen, right? So when I change x into twice x, but instead, this happened. Okay, let me say it again. I replaced x by twice x, and I got 8x cubed. From the previous transformation, I know that if this is x cubed, this will be 8x cubed. I'm exaggerating. But how did I obtain this? By changing x into twice x. So when x was replaced by 2x, the function suffered not a horizontal stretching as expected, because I multiplied it by 2, but horizontal shrinking by a factor of 1/2. It's just the opposite. A horizontal shrinking of the graph. So now I'm going to pick a problem from your book. Where are those? Okay, I see them, yes. On page 282, And I want the problem or problems 49 and 50. I have to copy the graph. Just give me a blink. So I have -4, -2. I have -2, 0. I have 0, 2. I have 1, 2, and 4. Okay, here's the graph. They're asking us to graph two things. A function called g, which is twice f of 1/2 x, and another function g that is 1/2 f of twice x. And then we'll write the transformation. What does it mean? Okay, this is a function that is given in the form of the graph. I don't have the expression of this function. But I am asked to perform the following transformations. Forget about this one, I just copied it so I don't have to go back to the book. So twice f of 1/2 x. So in number 1, the function is given. This is it. In number 2, which transformation will I apply first?
1/2 x.
Exactly. So I have to find or graph f of 1/2. I have the inside, I multiply 1/2 x by 1/2, and then I apply the function. Very good. What will be the last step or the last transformation here? Which is on function 2, not on function 1. Twice f of 1/2 x. Very good. So now, when I changed in the previous example, I replaced x by twice x. This was exactly the opposite of what I was expecting, a horizontal shrinking by a factor of 1/2. Now, what do you think is going to happen when I have to graph the function of, or I change x of this function into 1/2 x? Exactly. Because if you put 1/2, if you put 1/2 in here, you will have 1/8 times x cubed. And if this is x cubed, what will happen with 1/8 x cubed? This or this? This. That's the reason why when I change x into 1/2 x, the function will suffer horizontal stretching of the graph by a factor of whatever. So in this case, when I graph f of 1/2 x, for each x value, or each point, important point, not this one in the middle here, not this one or this one, but for the points that I have 5 points, their x coordinate will be multiplied by 2, not divided by 2. So this is at -4, the y value does not change, but the x value becomes -8. This, the y value doesn't change, but it's at -2. It will go to -4. For this point, the x value is 0, so we will not go anywhere. This point, the x value is 2. It will go over 4, or at x equals 4. And this is at 4, 5, 6, 7, 8. It will move to 8. This is f of 1/2 x. Final step. What transformation is this? So number 2 was a horizontal stretching by a factor of 2. So from here, please write it down. Horizontal stretching by a factor of 2. Now, what is number 3? What is transformation number 3 on function number 2? So this is y. and this is twice y. What happens with twice? No, twice y. Twice y. Twice y. Remember the absolute value? 3 times the absolute value. Vertical stretching by a factor of 2. So now all these brown points, their y value gets multiplied by 2. But that is not the opposite. That is exactly what it means. This is the opposite of what I would expect. So this value, this number, will multiply the height. So the height here is -2. It will go down to -4. The height here is 0. It will not go anywhere. The height here is at 2. It will go to 4. The height here is 2. It will go to 4. The height here is 4. Is 0. It will not go anywhere. So this is the final function. I just want to emphasize it because I don't know if you see colors or not. So this is twice f of 1/2 x. Yes?
So you multiply 2 by
That is a straightforward like before. It's a vertical stretching, yes. Remember the absolute value and 3 times the absolute value. Yep. Now, the other function, which is g of x, is 1/2 this one. I'll have to copy the graph one more time. Bear with me for 1 sec. 1, 2, 3, 4. 1, 2. 1, 2. 1, 2, 3, 4. Okay, here is the same graph of f of x. Now they want us to graph 1/2 f of 2x. What do I have to do first? Right, the f of 2x. What does that mean? This is the only one that is opposite. Everything else is straightforward. So here I'm told to multiply x by 2, but what am I really doing? Yes, it's a shrinking of horizontal shrinking, so I'm actually dividing it by 2. So this x value right here for this point is at -4. It will shrink to x equals -2. This x value is at -2. It will shrink to -1. This x value is at 0. It will shrink by staying at 0. This x value is at 2. It will shrink to 1. And this x value is at 4. It will shrink to 2. So this is f of twice x. Now, final step. What will I do to determine or graph 1/2 f of twice x? All y values get multiplied by 1/2. So this is at -2. It will go to -1. This y value is at 0. It will stay at 0. For this point, this y value is at 2. It will go to 1. This y value is at 2. It will go to 1 because I'm multiplying it by 1/2. And this y value is at 0. It will stay at 0. This is 1/2 f of twice x. So the only one that is not straightforward that you should remember is twice x does not mean this. It means this by 1/2. 1/2 x does not mean this. It means this by a factor of 2. Everything else is straightforward. Okay, let's practice a little bit more. So, for example, in case you are wondering, I did say that last time, why we need to understand transformations is for problem 128, for example. They measured these kids from 0 month till 60 months. They measured them constantly. So, and they came up with a graph. So when they measured them, let me just copy the graph. So here's the graph. from 0 to 60 months. So this is their height. And a mathematician came along and said, oh, I know. So this is a square root function. So they measured this, which is a starting point, and they said, oh, it's 19 inches. So then through the model, they came up with a function, and they gave it to us, 3.1, the square root of x plus 19. So what transformations are involved here? So first of all, I have the square root of x. I have to get rid of these. Square root of x, then multiplied by 3.1 will be this. And then up 19. So 3.1 the square root of x plus 19. So, and the question is asking us, describe how the graph can be obtained. We already did. The square root of x, vertical stretching, yes.
You went up twice. Why did you go up twice?
No, this is multiplied by 3.1. This is still starts at 0. The second one still starts at 0. So this is the square root of x. This is 3.1 times the square root of x. So I have to multiply all heights by 3. This should be multiplied by 3 to get this. This should be multiplied by 3 to get this. This should be multiplied by 3 to get this. It's even more than what I graphed. Should have been a little bit more exaggerated. And then this was taken up 19. So describe, we already did. According to the model, what is the median height of girls who are 40 months, 48 months, or 4 years old? Use a calculator and run to the nearest tenth. The actual median height is such and such. So f of x gives the median height. So we're asked to find the median height for 48 months. So when x equals 48 months. So this is problem 128 on page 284. How do I determine the average? It's the median height. This is f of x. Median height. How do I determine the median height when x is 48? Right. So I have to find f of 48, which is 3.1, the square root of 48 plus 19. And I grab my calculator. 3.1 times the square root of 48, and I get plus 19. So it's 40.48 roughly inches. It says the actual median height for girls at 48 months is 40.2. So the actual is 40.2 inches. How well does the model describe the actual height? Say it again.
It was like it's close enough.
Very good. It's a very good model. Very good model. At least at 48. I don't know. Maybe at 60 won't be. I don't know that. But at 48 is definitely good. Use the model to find the average rate of change in inches per month between birth and 10. Average rate of change between birth and 48 months. Birth and 10, I'm sorry. How do I find the average rate of change for this function between 0 and 10? Yes, it's the slope, of course. So f of 10 minus f of 0 over 10 minus 0. So f of 10 will be 3.1 times the square root of 10 plus 19. And f of 0 is, when I plug in 0, I just get 19 divided by 10. So I'll use my calculator. I have 3.1 multiplied by the square root of 10. And I divide the whole thing by 10. Okay, well, I got 0.98. So 0.98 what? Per? Yes. Because remember, the average rate of change has a measurement unit for the top and a different measurement unit for the bottom. So that's why this is inches per month. So what does it mean? between between birth and 10 months old, their height on average increased by roughly 1 inch. Okay, use the model to find the average rate of change in inches per month, of course, between 50 and 60 months. How do I get the average rate of change between 50 and 60? Average rate of change between 50 and 60. What do I have to write? Yes, but 60. F of 50 minus F of 50 over 60 minus 50. So this is 3.1, the square root of 60 plus 19 minus 3.1, the square root of 50 minus 19. I have to subtract both, divided by 10. So I will calculate 3.1 times the square root of 60 and minus 3.1 times the square root of 50. Any questions? Divided by 10, I got roughly 0.21 measurement unit. How does this compare with your answer in part C? How is it this difference is shown in the graph? Okay. So let's go back to the graph for a moment. So this is 50, and this is 60, and this is 10. So between this point and this point, and between this point and this point. So I'm telling you that the slope of this line is how much? Approximately 1 inch per month. And I'm telling you that the slope of this line is approximately, slope, of course, M, is approximately to 1 inches per month. Does it make sense? Is this a steeper slope than this one? Of course, this is much steeper. You don't want to hike on this. You would rather hike on this, right? So this is much steeper than this. So it makes sense because between 0 and 10 months, kids grow much faster than between 50 and 60, right? It slows down. Good. So this is a typical type of situation that used transformations on the square root of x to find this model. It's not easy at all to find a model like this. And once you find it, it doesn't necessarily mean that it's going to work for each and every point. Well, like it works for, yeah. Any questions? Any questions? Okay. I would like to discuss, this is a topic from the previous course. It's function, it's in the book it's called combinations of functions, but it's basically algebra of functions. I'm going to call it combinations, so 2.6. Combinations of functions. And function composition. By combinations of functions, we really mean a sum of two functions, a difference of two functions, a product of two functions, and a ratio of two functions. By function composition, we mean f comp g, or g comp f, or any other combo. So what are these? Well, again, these are ways of finding new functions if I'm given at least two. So if I'm given two functions, I can add them and create a new one. I can subtract them and create a new one. I can multiply them, create a new one. I can divide them, create another function, or use function composition to create new functions. So what will this mean? If I'm told here, f, here, g, find f plus g, what will you do?
The sum, add them together.
Say it again.
The sum, add them together.
Yes, very good. F of x plus g of x. How will you find the function if I say here's f, here's g, find f minus g? What would you write?
x minus g of x.
If I say now find f times g, how will you determine that? F of x multiplied by g of x. And what about this? This is the only one that for which I will write a comma and I will write an if. I did not need the if for the other ones, but here I do. If what? Excellent. Very good. Now, there is a problem with the first four. I'm going to say problem. And here's the problem. Sum difference product ratio of functions exist only if the functions have a common what? Starts with D. Domain. If one of them is defined in Australia and one of them is defined in Maryland, you can't add them because they don't exist for the same x. One is defined over there, the other one is defined over here. For x equals 5, only this one is defined and that one is not. So if there is no common domain, these functions cannot be created. And I want to start with the problem on page 297. Like problem 10. F of x equals 1 over x plus 8 plus 3 over x minus 10. And you could say, wait a minute, what is this? And I'll say, this is g of x, and this is h of x. This is f is a function determined by making the sum of g and h. So can anyone give us the domain of g? Anything but negative 8. Negative infinity, negative 8, union negative 8 to infinity. Can anyone give us the domain of h?
Negative 10.
Anything but
Negative.
10. So negative infinity 10, union 10 to infinity. Now please, someone give us the domain of f. And it must be the common domain. So you are g, and you don't have negative 8. I'm h, and I don't have 10. What is the common domain?
All wrong numbers. Negative 8. Negative 10.
So you have everything but negative 8. I have everything but 10. What do we have in common?
2.
Everything
Five.
except negative 8.
Exactly.
Oh.
You don't have negative 8, and I don't have 10. You do have 10. I do have negative 8, but that's not common. So that's the common domain for f, the common of these two. So this is negative infinity, negative 8, union negative 8, 10, union 10, infinity. So that's how important the common domain is. I will not be able to add these two functions. For what values? 10 or? Right, because one or the other doesn't exist. Very good. Now for example 26, I still have time, yes. 26. H of x equals the square root of x minus 3 plus the square root of x plus 4. Again, you can say, okay, what is this? Well, it's the same situation. I have h, which is the sum of two functions. Let's say function 1 and function 2. What will be the domain of function 1? I have to write something, solve it, and then I'll figure out the domain. What do I have to write? That x minus 3 must be, so I can take the square root from it, must be, say it again, or 0, right? So the square root cannot be applied to anything else but positive or 0. So then this means x greater than or equal to 3. So the domain of function 1 is 3 to infinity. Can anyone give us the domain of function 2? You have to write x plus 4 greater than or equal to 0, which means x greater than or equal to negative 4. What will be the domain of f2? Now I need the common domain. And then before you say anything, allow me to graph them. 0. I don't need units. Don't bother with units. So 3 to infinity. And a negative 4 to infinity. So then what is the domain of h? Careful. Yes? Because they both have to exist at the same time. Between negative 4 and 3, one of them doesn't exist. You have to see both colors. Both have to exist at the same time. So then the domain of f is definitely 3 to infinity. And this is the common domain. I'd like to look at one more and then I'll stop. Like 27. G of x equals the square root of x minus 2 divided by x minus 5. I need to find the domain of this function. I have to state all restrictions that are needed here and then intersect. And I just remember that I wanted to show you at least one of these transformations that my department chose. So I don't want to forget. Next time, please remind me. And there was something else about homework. I don't want to forget. Okay. So what is the first condition you will write? Very good. X minus 5 cannot be 0 because it's in the denominator. Okay. What is the second condition that you have to state? No, we're talking about this quantity. It's under the square root. Yeah, no, it's x minus 2. I cannot separate. So the quantity under the square root must be greater than or equal to 0. We cannot take the square root if it's negative. Okay, so this means x greater than or equal to 2. So when I look at the real line, greater than or equal to 2 is this, but x not equal 5 is this. So the domain of G, please. That's it. So the idea of the domain or the concept of the domain is extremely important.